Welcome. We'd like to do a double interpolation. So if we have some steam properties that we need, let's say we need the enthalpy for 460 psi absolute and 700 degrees Fahrenheit. We don't have those in the tables. When we look at the tables, we can come into Babcock and Wilcox, and we can see we've got the 700 and 800 degree temperatures. And we've also got pressures of 400 and 500, but we don't have the 460 psi. It's right in here, nor the 807, the 720 degrees. So we're going to need to do some interpolation between both of these. And so when we look at these numbers, we can come across, we want our 400 psi right here, we want the 460, and so we can come in here and come across, we look at the temperature, which is going to be a 700 right up there and an 800 right up there, and draw a little crooked, and 700, 800, and that's going to give us these values of the enthalpy, which is right there, the 1307. Make sure I got the right column here. Let's see, we got the 13.7, and I'll have to 1357 for the low at the 700 degrees Fahrenheit, and the 1363 right there, and then the 1417 and the 1412.7 BTUs per pound. So we bring these numbers across from our tables, and let's look at it from a pressure perspective. So we're going to be looking at it from start with the high pressure, 500 psi, and that's absolute. So we're looking at this 500 psi perspective right here, and so we want the values, and so we're going to have it essentially from the perspective, what I'm thinking is we're going to be looking at the temperatures at the different psi. So let's run with the temperatures. We've got 800 degrees Fahrenheit. Then, as we know with the interpolation, we want the 720 degrees Fahrenheit. And we've got also a number for 700 degrees Fahrenheit. And then just like we do that, we're going to be looking at the combination from these. And that's going to correlate with our 1412, 800, 500, so with 1412.7 BTUs per pound. We don't know what this number is, and then we've got the 1357, that's a 7.7 right there for that value. And so that's going to mean that we'll look at the interpolation process. We'll take the 720 minus our 700 and divide that by our 800. So we're taking the ratios across there by our 700. And that ratio is going to be equal to, a little better parenthesis, that ratio is going to be to the H value at the 720 high pressure minus our 1357, we want that ratio, 57.7, and we're going to divide that by our 1412.7 minus the 1357.7 there. And so when we look at these numbers, we're going to take the 720, that's going to give us a 20 divided by 100. Or 0.2, 0.2 right there, and then we'll want to make that equal to our H, 1457.7, and that will give us this number divided by that is going to give us 55, not divided but subtracted, and that means we're going to end up with our 0.2 times 55, which is that value right there. And then we're going to need to add this number back over. Let me just start this. That's going to, so we don't get confused. That's going to, oops, better not do that one. It's going to be a minus the 7.7. And let's see if we can get this to scroll down a little bit. There we go. Going to need to take that value and put it onto the other side of the equation. So we've got the 0.2 times our 55, and we're going to need to take this 1357, subtract or add it, since we've got the, in that case, so we're going to need to add that back in, 1357.7, and that's going to give us our H value right there, which we're going to put that all together. We're going to end up with 1368.7, and that's at the 720 degrees Fahrenheit and 500 psi. The absolute in there. Okay, just did a little rearranging there too, so we can see what's happening. So now we're going to need the same thing, but we're going to want to do it at the 400 psi. So we've got the 400 psi point, so we can find the enthalpy working at this 500 psi. We want to bring it down to the 400. So again, we've got this same ratio right there, which is going to be the 800. Look at it that we've already done this particular ratio right there, and we ended up with the point 0.2. So we can look at the concept that 0.2, and that's going to be equal to, in this case, we're going to be looking at the 400 psi. So if we come up at 400 psi, we're going to see that it's 1417 and 1363, but we want, so we're going to want the H 720 low, I guess we could call that, is going to be that number, and we're looking at the lower PSI right there, 1363. Excuse me, I put a equal sign there. That should be a minus. Let's see if we can get that. So it's going to be minus our 1363.4, which is, we're looking at the 700 degree, or 400 psi state, I should say. That's going to be the 1363.4, and that's all going to be divided by our 400 psi value right there, the 1417. 1417.0 minus our 1363.4. That we can take our 0.2 and hopefully understand that this 0.2 is really just that number right there, and multiply that by our 1417.0 minus our 1363.4, and that's going to give us the equal to the H720 low, 1363.4, and we're going to want to bring this out, so let's add that to both sides of the equation. So we got our 0.2, and this number right there is going to give us, and get this number right there, that's going to be the 53.6. That's gonna, then we're gonna add this number to it, so we'll add that number 1363.4, and when we work this out, we're gonna end up with 1374.1. I'll put the 1, 2 in there. So that'll give us the enthalpy at the 720. That's going to be 720 Fahrenheit, 400 psi value. So now we need to look at, let's take it back and we work the psi in this perspective. We'll need to take these values right there and put those into the other part of the equation, come in from the other direction. So we did on the first part, we came in, looked at it from, you could think of, going this direction and that direction on the table, so forth. So hopefully that made sense. And I can probably, so when we come in and look at, now we're going to be looking at it from the psi perspective. So we need to know what it is going to be at our, that's going to be the 460 psi. So let's look at the temperature. Let's look at it from the perspective of the temperature of the 720 degrees Fahrenheit. And so we're going to be needing need this value right there, the 13. Back up and get everything in the right side of the equation. So we're going to be needing the 500 psi. And we're going to be using, we want the 460 psi absolute, and we want the 400 psi. That's going to be equal to, we've got this value right here, 1368.7. 68.7, and we don't know what it is at 460, but we do know at this number at 400, 720 and 400 psi, we've got the 1374.12. And from here, now we can just do our routine that we do. We're going to take our ratio here and our ratio there, and then do the same ratio perspectives over there, just like we've been doing with the interpolation. Took the liberty to just put the equations down so you could see them. Here we've got essentially the same ratio, and that's going to be equal to this on the interpolation. So that's equal to 0.6. That over to that side of the equation, those values, and then add that in, subtract that side, and then bring it in there, and that's going to be equal to our final enthalpy, which essentially is going to turn into, we're going to be able to get that number is right there. So we got 1370.9 BTUs per pound mass for the enthalpy at, so that's going to be at 460 psi absolute and 720 degrees Fahrenheit. I also had the opportunity to, I thought it was interesting, in this case I started and took the whole process using the Fahrenheit, the PSI, looking at it from the PSI's perspective, and then coming in and using the temperatures. And it was interesting to note that if I came in from the other direction and used the pressure to start with, we're going to end up with, just run through the entire equations again, and when it comes down we ended up with this 1370.9. So whichever direction you want to start, you can either use the temperatures or the pressures, and you'll end up with 1370.9 in this case, and go 1370.9 in that case. So there's a case of double interpolation, just to give you some insight on how that will work.